Hello and welcome to Programming Like It's 1979. Once again, we are going to do a Let's Play of a programming game. This is Manufactoria 2022. Now, this is a remake of a classic Flash-based programming game. I first saw it back in 2010 on Congregate. The developer, Pleasing Fungus Games, has made a number of other games, including some programming games. The one that springs to mind for me is Silicon Zeros. This game is available on Steam. It is in early access, so if you're watching this after it's been released, things may have changed since you've seen this video. Well, let's jump right in here, and we have some various things here to do with settings, but I'm just gonna jump right in. Oh no, I got fired. Department-wide streamlining, so someone has been downsized. But this person has a skill, which is making toy robots. It's their dream, their childhood dream. So let's go ahead and click, and we have here what looks like a map. A lot of these programming games are sort of level-based and have you unlock the levels in sequence. So we have not yet started to build this robot, so let's go ahead and do it. I started by making robots that did exactly nothing. All right, so Manufactoria 2022, the basic goal of almost every level is to take a robot from the entrance and guide it to the exit. And when I say a robot, it could be any number of robots, and they could be robots with certain characteristics. But on this level, all we have to do is essentially move some things. So we have WASD, which seems to change the direction of the, what is it? It's a conveyor belt. And we can start putting things down. We can drag, click and drag. We could do something kind of more involved, but for right now, let's just go top to bottom and click run. Great. Obviously, this is something of a tutorial level. All right, stamp bots. I don't like that it doesn't tell me what the mission is until I actually click. That seems like I don't understand what the UI purpose of that click is. Program the robot with, looks like either power, sleep, sleep, or red, blue, blue. I think these are fairly abstract. So this is something that's a little bit interesting. I'm going to hold down the R key here. Actually, I don't have to hold it down. Looks like 1 is red and 2 is blue. And I want to stamp this with red, blue, blue. So we're going to go red. I'm going to tap 2, blue, blue. And I think the arrow indicates that this machine will move it on to the next level. So you might think this is just a game, but this concept of symbols on a paper tape is in fact the Turing machine conception of a computer. So my belief, although we haven't yet gotten there, is that this is going to be used, we're going to be doing things like sorting and searching based on the symbols on the paper tape. All right. Kid who bought one told me the robot would look great on social media. Well, there you go. Feel free to share this video on Twitter. All right, so now we have a main path, which goes this way, and then kind of a dead end. Very often these dead ends can be interesting or advanced techniques in this type of game. So let's go ahead and click there. Could a robot truly create art or music? Use the pipes to produce red, blue, red, red, blue, blue. And these are fixed in place. So we're being told to use pipe. What does a pipe do? So we're going to go here, and then we're going to go here. All right, so it looks like what the pipe does, a pipe is like a conveyor belt, but allows things to move straight through it in more than one direction. So we're going here, then we're going here, here. Then this must not be a pipe. This must be... Well, it should be a pipe. It's going to go up there. This can't be a pipe because there's a corner, and in fact, this is wrong as well. These have to be conveyor belts because they are changing direction. I think that might be it. Let's see if I'm wrong. You can see on the bottom of the screen here, the symbols are being stamped onto the paper tape. I guess they don't explicitly call it a paper tape, but that's certainly how I think of it. I'm thinking of this as a Turing machine. Onward. No scores as near as I can tell yet. Looking for more challenges. We're going to do mazes. Place an entrance and an exit. So that's over here. We've got F to place an entrance and V to place an exit. We need to go blue, red, red, blue, red. Okay, so blue, red, red, blue, red. So if this... No, that can't be right. Well, let's try it. Blue. I don't know if there's any advantage in using a pipe versus a conveyor belt. Blue, red, red. We go here. Now, see, that can't work because then we're stuck there. Oh, I see. We can place the entrance here, pointing up. And then these become just conveyor belts. Blue, red, red. And then our exit goes here. Lovely. It's easy to make a maze-solving robot, but surprisingly hard to make an interesting set of mazes to solve. Very true. So we've unlocked factory reset. What is that about? Remove commands from the robot's tape before producing it to the exit. Oh, it is. They call it a tape. That's great. So I didn't just make that up. We have scanners. If there's a red or blue at the start of this tape, removes it and sends the robot in the matching direction. Otherwise, it sends the robot straight out. So this is both a conditional and a consumer. It's going to actually eat whatever is on the tape. So we want to remove all commands. So if either red or blue are on the tape, then... Oops, that did not mean to do that. I meant to do that. If neither red nor blue are on tape, then that's presumably that white arrow is, and it will go straight that way. So we'll put the exit there. So you could put multiples of these in sequence, but I think the obvious thing to do here, I don't know if this will work, let's try it, is if a red or a blue is found, just put it back into the exact same conditional. Let's see what happens. Great. Now, is that as efficient as this could be? I don't know if I care, but... Oh, wait, we got a little... You got a medal for the number of scanners and stampers. Okay, so we had the minimum number of scanners. Aha, look at that. Global stats. So... So I was not as fast as can be. I was as efficient in terms of scanners and stampers. Now this is interesting. Area. 30% of players had area 4 or less. All right, I don't actually care about this, but I want to at least take a look. So how would we get an area of 4? Wow. That seems awfully hard. What if, could we do something? Ah, yes. Okay. So if we do this, I don't know how a T to get rid of something. Good. We do that, and then that goes there. And this is our exit, right? That's still an area of, that's still too big, right? That's 6, not 4. Well, let's do it and just make sure that our understanding of how it all works is correct. Okay. Well, we definitely had a smaller area. It's unclear to me how I would get 4. I mean, an area of 4 would imply, and I'm not actually, this is not meaningful, but, right? Like that would be what we'd be looking at. How would we even do that? Unless there's some behavior. You know what? Let's try it. I don't think this is going to work, but I want to at least test the theory. Unless, like, it's going to bounce back somehow. I think it's going to hit the corner of the... No. No, this is... I don't see how they're doing it. Let's see, red is the first one, so let's see what happens if something goes off the edge. Okay, so that's kind of what I would expect, is that it blew up. We can... Oh, and over here it looks like we could step through a tick at a time. So that's exciting. Yeah, I still don't see how you do this one in 4 or less. Load your... Ooh, this is nice. Lots of nice little UI touches here. Load your successful solution with the best runtime, fewest scanners, and smallest area. I wonder if there is some sort of control that we have not seen yet that hasn't been introduced. Lullabot. My friends told me about their kids crying and screaming all night, and it sounded like a real hassle. What if a robot could gently sing the kids back to sleep instead? $1 million idea. Replace all the reds with blues and then produce. Well, that sounds exciting. Okay. I think we could use our newfound knowledge here. No, we can't. Oh, well. Well, let's just do it the most straightforward way possible. We know there will be nothing blue that we can think of, that I can think of. And so we want to stamp with blue and send it back. Right? And actually, I don't think the tape is ever going to be empty. I think that is what we want. Let's take a look. You know what? This is a good time to pause. And we can go to the next machine. Or go to the next tick. Watch it. We can go forwards. We can go backwards. And there's a fast forward button. Let's try that. Goes a little bit faster. We can see the tape. Nope. We made a mistake. What happened here? Well... Congratulations, even when building robots, we can have off by 1 errors. What just happened there? I got an achievement of some sort. Where to? I see. We actually need a final stamp to solve our off by 1 error, which is a terrible solution, but, you know, life is hard. Let's try it. And let's use our newfound fast-forward powers. Great. All right, so we have now finished. Oh, we got a little award there. So we got the We did it in the shortest amount of time, but we did not, again, can I see my friends here? Let's see. Oh, there's Quentin. Beating me like always. Oh, I guess I beat him there. All right. He'll watch this video and then he'll come back with much better solutions. All right, so now we have unlocked a new story beat. Oh, we're starting the venture capital thing. This guy really likes making programming games where small companies get VC to try to expand. I wonder if this is close to his or her heart. All right. With a freshly rented factory and a frankly alarming amount of money in the bank, there would be no more locally made, artisanally crafted toy robots. Time to build on an industrial scale. Time to get serious. Failures. We have a new control, which is the junker, which allows us to reject a robot. Junk robots that enter your assembly line with empty tape. Produce the rest to the exit. All right, so we need an entrance, clearly. We need a sensor. Actually, that's not an entrance, is it? That's an exit. Try that again. We need an entrance. Let's point it up. We need a sensor. Now, this is an interesting question here. The implication here is that it's only when it enters with an empty tape. But the minute I put a robot through a sensor, it's going to consume a stamp, and then the tape will be empty, but that is not to be junked, right? I think that's what I understood. So let's just go ahead and do the obvious thing here. We want the junker there. So we could do this two ways. We could put two exits like so, or we could kind of build a little conveyor belt to bring these two things to a common exit. Let's do this because it seems more obvious. Great. And I liked it. Oh, and apparently that was the only solution, maybe, or the best solution. Candidate picker. Produce only robots that enter with blue at the start of their tape. Junk the rest. Okay. Well, again, I think this is really the same logic, almost. Or very similar. Blue, and those get produced, and then everything else gets junked, right? That's every branch, I think. Oh, we could even be cuter. So this is a case where, since the eventual result is to junk it. Sorry, I'm going to try and be a little more efficient here because I want to be. We can take this one and make it so that red goes back. Let's get rid of all this. Okay. And then what happens here? I guess it has to be the same direction. So that saves us one junker, I think. And that's a junker, and then that's the exit, right? And what'll happen here is if they are red, they will keep going through the conditionals, which will consume the tape. And thus eventually we'll get to a failure state. Accepted a robot that should have been tossed into the fire. Okay. Let's see. What did we do wrong there? So here's a robot. It's got red... Oh, son of a gun. No, my brilliant idea didn't work. Okay, let's do the simple thing then. We'll go back to plan A. And then this becomes a junker. That becomes a junker. Here a junk, there a junk. Everywhere a junk. I think that'll work. Same thing. What was that happened? Blue, red, blue, blue. Okay, well, what if we take this one and turn it that way? So if it's clear, if it's empty, it'll go back here and then be junk there. Put our exit here. That goes away, and that gets a junker. Not too bad. We're writing unit tests. How about that? Well, we have some choices. Create expectations. Well, I have to click on it just because they named it Create Expectations. Junk robots that start with red, blue, and produce the rest. Right-click to grab machines. I see. So red and blue. I see. I can't actually... This is just teaching us some UI. They've disabled all the UI for selecting things, and they want us to grab those and drop them like so. What'd they say? Red, blue, and junk the rest. No, I can't do that. Grab, drop, 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 drop. We're like stamping. Can I trash things? No. Rejected a perfectly good robot. Oh, I have it exactly backwards. How silly. Junk robots and produce the rest. There we go. That should work. Read carefully, kids. That's the lesson here. Obviously did not... No. Are there actually... there's no best time for this one, so I don't have to worry about that. Tests on demand. Using the test mode, produce a robot with red, blue, red. Okay. Red, blue, red. I see. This just lets you put something arbitrary on the tape so that you can run it through your machine. That's nice. Advanced testing. Using the test mode, click. Produce a robot which has red, blue, blue, red. Well, this is going to consume one. So we want it to be blue, and then it'll... I think we want it to be blue... No. And it's going to stamp one on the end. So we want it to be blue, red, blue, blue, and it will stamp a red on the end, I think. Eats the blue, stamps the red, there we go, great. That wasn't very interesting, I gotta tell you. Oh, we've hired our first slimy marketing person. Pleasing Fungus really likes making fun of marketing people. Here's our salesperson. Now, in Silicon Zeros, our first salesperson, Jack, ended up stealing a bunch of stuff from the company. So I think what we will do is we will finish this screen And then that will be a good place to stop. I think that's a good size introduction to Manufactoria 2022. And if you like what you've seen, you can pick it up on early access on Steam. So, Super Sprayer, a shower head that follows its owner around the tub and runs a head-to-toe spray down. Sounds great. Junk robots that enter with any red on their tape. Okay, so we're starting to get to the search functionality that I've implied would probably be coming too soon. Well, the only way to know if something has a red on its tape or in its data set is to look at every item in the set. So we know that the runtime for this is going to be at least O of n, right? So let's see. We can do this. If we find any red at all, we're going to junk the robot, reading carefully. And if it doesn't have red, then we're going to... Oh, this is a case where I can... This is a case where I can do that trick like so. That's the junker. Get rid of that. At this point, the tape will be empty, and the exit goes here. That's looking pretty good. Got the area medal and the number level. We did not get the time award. I'm curious what the best time for this is. Yeah, I don't see how you... This feels almost like... I mean, how is that... How is what we built not a minimal machine? I don't know. All right, let's do the Lathertron next. An auto loofah. Ooh, that sounds terrible. Produce robots that enter with all of their blue before all of their red. Junk the rest. All of their blue before all of their red. So first of all, there's some questions that I have here. And the first question is, what is... I can't actually do that while editing or while not editing. My first question is, what's the goal for a completely blank tape? Right? So let's run the test. Well, robot handled right. Let's do this. All of their blue before all of their red. So we know that. Okay, so as we adjust the tape, it is changing the goal for us. So that's great. So the complexity here is that an empty tape is meant to be produced, and a tape with no red is meant to be produced. And a tape with red on the end is meant to be produced. It's only when we have a red before a blue. Right? So, therefore, the key decision we have to make here is there red? Right? So this is going to be our first conditional. And if we get here and the tape is already empty, that's fine. If we get to a blue, then that's fine too, except we still have more work to do, right? This over here is the critical section. So we get a red. So now I'm going to deliberately use more space here. I want to just separate this in my mind. So now we've got a red. And if we get more reds, that's fine. And if we get a red and then an empty, that's fine too. This is wrong, by the way. But if we get a blue after a red, then that's junk, right? Yes. And then if we get a red we can just point that back that way, I think. All right, so now I don't need this. Move all these over one. And this needs to be like so. This feels not as efficient as it could be, and I'm totally not going to worry about it. Correctness first, efficiency later. Of course, in the case of this video, efficiency never. What do we get? Time? Number of scanners. All right. Folder 0L. Folding clothes, sheets, and other sundries can take a while. Produce robots with an even number of commands, and 0 is even. Ooh. Boy. Okay, so we don't care if they're red or blue. The only thing we care about is, are there pairs of red or blue? And empty, completely empty is fine. All right, well, again, I'm not going to worry about efficiency. Let's do this from the left just to mix things up. All right, so what's our first decision? Very first decision is if it's completely empty, it's good. That's our if null case. And then we're going to have another one, right? So now, oh, sorry. This is the case where no, empty is fine. That's right. So now we're getting here. Oh, this is tricky, isn't it? Because at this point, all right, at this point, empty would be crushed. No, 1. Right, and that would be a crusher. But the problem here is, as you can see, what we almost want to do is bring it back around. I think we need more space. Okay. Oh, I feel terrible about this. This is not making me feel good, but I'm going to do it anyway. If I start worrying about efficiency, that way lies madness. So I am going to be 100% garbage pile about efficiency, right? And that goes there. And then this is going to do the same sort of thing. And I'm la la la, I'm not looking, I don't care that it's not efficient. Yep. Boy, that's awful. I'm having a crisis here because I'm going to look at the leaderboard and I'm going to be very depressed because there's no way that is not. Yeah, look at that. 93% of players did better than me on time. 93%. This is like the story of my life. And of course, area is bad, but I really don't care about that. I did, however, do it with only 2 scanners. So I guess I could feel good about that. That one is difficulty 3. Let's save it for the end, and that way I can skip it if I need to. Home delivery. Produce only robots that enter with blue, blue, blue in a row anywhere in their tape. Oh my God. Junk the rest. How do you do that? Well, I think I'm not going to put the entrance in. Interesting that this one clearly is giving us more space to work with, which I think is something of a hint. What I'm going to do is put blue, blue, blue. No, that doesn't work, does it? That doesn't work because if we go backwards, that won't help. Let's do blue, blue, blue. right? So if anything comes in here and gets blue, blue, blue anywhere, there it goes, right there. If it reaches the end, all of these white spots, we should never reach the end of the tape without producing a successful robot. So then the only thing that matters is these guys. If we find anything else, we go back. Oh, this is terrible. Again, with the efficiency. I'm not worried about it. I'm just not. I can't. Life is too short for me to get hung up on efficiency in a YouTube video. I'm sorry. That's how I feel. And right. I think that'll work. All right. After I got the robot working, Marcus told me to misprogram it to crush phones instead, and then release slow-mo footage online. Okay. Well, now we got 2 of these, and all right, so this is I've seen this in Silicon Zeros and his other games. These 2 here are more difficult. And then we've actually opened up the next level. All right, well, let's take a look and see. At least we'll look at what the complexity of a 3 circuit board puzzle is. Produce robots that enter with an odd number of red and an odd number of blue. Junk the rest. Oh my goodness, that is pretty complicated, right? Produce robots. So this is interesting because it has memory, doesn't it? In a way. For us to know that there's an odd number of blues on this tape down here, we have to be in a sort of state. So the minute I say that word state, that makes me think of some sort of state machine. So what is our state machine? Well, all right, so the failure state is we reach the end of the tape and we are not yet in the state where there is an even number of, an odd number of reds or blues. And furthermore, we know, I'm going to start down here. We know that we're starting this mission in a valid state, right? We're starting with an invalid state. Produce robots that enter with an odd number of red and an odd number of blue. So if something comes in on the paper tape and it's got no stamps on it, we know immediately it's garbage, right? We can junk that right away. Okay. So now if we come through and we get a blue. Now we're in a state where blue is correct, but red is not. Okay. So if we're here, we know this is state 2. Blue is correct, red is not. That gets junked. If we get another blue, at that point, we're back to the beginning. I can already tell I'm running out of space here. If we are here, we got 1 red. This is in fact the good state. We've got an odd number on this conveyor here. We've got an odd number of... On this conveyor here, we've got an odd number of blues and an odd number of reds. And at that point, we're done. Okay. So that's actually the blue side. On the red side, If we reach the end of the tape, we have one red and no blues. So that's trash. If we get another red, then we're going back to the beginning, right? If we get a blue, we're in the good state. I think that might be it. That might be it. I don't know. Seems too easy. Let's see what happens. Okay, we got a failure. Great. Blue. Oh, you son of a... Oh, okay. That is a syntax error. We literally just had a bad conveyor belt. Gotta tell you, I'm not, at this point, I don't feel like I need to use pipes. Oh, another bad one. Let's see, it's got one red and one blue. Okay, so that's interesting. So we missed a very obvious case here. And I think what that means is we're in a good state on this conveyor belt. If that's the last one, then we're done. If that's not the last one, and another blue comes in, oh, this is awful. So if a blue comes in at this point, then we would be in the red is good, but blue is not state. Which is going to bring us back here. Right? And if a red comes in, then we're in the... Wait, did I do that right? Okay, so we're coming here. Everyone has an odd. We get a blue. Now red is good and blue is not, which indeed does bring us back there. If we get a red, then blue is good and red is not, which are these two over here, and I am screwed, I think, because I have not left myself enough room. All right, let's do our... There's a reason why they introduced this feature here. Okay. And we'll put a pipe there. And this time, I'm going to get us back to here. So, blue, red, everything's copacetic. Then we get another red, or blue is still okay. That's going to bring us there. Well, let's see. Did we do this right? Nope. Blue and blue. Oh, because again, this is essentially a syntax error. I moved everything up, and therefore we needed another one of those. 3 reds. Okay, so that's odd. Not sure I understood that. Okay, so 1 red goes there, right? Ah, we wanted this one to go back to the beginning. That's why. And so this needs to be one of those. Boy, this one is twisting my brain around. For sales, it doesn't matter how well something works or how useful it was. As long as it seemed like the biggest and most futuristic product around, buyers would come. I feel like that gives us a taste for what the more complicated puzzles are going to look like. So, this is Manufactoria 2022. It is $19.99 on Steam right now as an early access game. I really love the work that Pleasing Fungus Games has been doing, and I look forward to seeing how this one develops. This has been Gaming Like It's 1979. Thanks for watching.